Hey guys, so here's part 2 of the 2.7 Extension Day 2 notes. We're going to be talking about how to graph piecewise functions. Now, just like when we graphed linear with those restrictions on our 2.7 Extension Day 1, we used XY tables. We're going to do the same thing. So basically, the number of equations you have, that's the number of XY tables you should have, okay? So here, we're going to say the first one is for the 2x minus 1, and then the other one's going to be for the 3x plus 1. Now, how do we decide where to start? Well, remember, we always start at the restriction. So for our equation of 2x minus 1, we start at 1. Now, looking at the restriction, our inequality is saying x is less than or equal to 1. So we need to determine, do we want x values that are smaller than 1 or bigger? We want smaller. So that's going to include like 0, -1, and -2. So I would advise, because you're probably going to have, we want to graph about 4 or 5 points, okay? And that's including your starting point. Okay, now from there, we're going to go ahead and plug these numbers back into the original equation of 2x minus 1 to get our points. Okay, so when we plug that 1 in, we get 1. When we plug 0 in, we get -1. When we plug -1, we get -3, and then -2 is -5. Now, we go ahead and plot these points. Now, our starting point is at 1, 1. And so, since that's our starting point, we need to decide if this is going to be an open or closed circle. Well, notice because we have an equal bar, that means we are going to have a closed circle. So I first graph 1, 1. And close. And then everything else is also going to be closed. I do 0, -1, and then -1, -3, and then -2. There we go. Now make sure when we graph this, we go from the starting point, which is 1, 1, and connect the rest of the dots, and then do an arrow. Okay, now we're going to do the same thing with our 3x plus 1. Don't forget, we always start at the restriction. So even on the 3x plus 1, though there's no equal bar on the x is greater than 1, we start there. Because the idea is that we need numbers greater than 1, and there's infinitely many numbers. So we just start at 1. Now, since it says x is greater than 1, do we want numbers larger or smaller? Larger. So maybe 2, 3, and 4 will work. Now we plug these into our 3x plus 1. So when I plug 1 into there, I get 4. When I do the other one, I get 7. Then I get 10. And then I get 13. So now, 1, 4 is our starting point. And I have to decide if this point is going to be open or closed. Well, because there is no equal bar on the x is greater than 1, it's going to be an open circle. But all the other points are going to be closed. So I go to 1 up 4, and I do an open circle. Now I graph the other points like normal. So I do 2, 7. And here, because the 4, 13 goes off the graph, I'm not going to graph that. Now I go from the open circle, connect the other points, and then I have an arrow. So notice we are going to graph raised like we've done before. Okay? So now that I've graphed it, that's all I have to do there. And I've graphed my piecewise function. Okay, now let's go ahead, let's try another one, but now that we have 3 equations. Now remember, the number of equations tell you how many xy tables we need to do. So we're going to have the -3 have x minus 1, and then in the middle we'll have the x plus 1, and at the end it's just going to be the 3. Okay? Okay, so we're going to do the same thing. So on the -3 halves x minus 1, we start at the restrictions. We always start, no matter if there is or is not an equal bar, we always start at the restriction. So since we have x is less than -2, we start at -2. Once again, I'm going to pick maybe 3 more points. Now, if x is less than, are we going to choose bigger or smaller numbers than -2? Smaller, so that's going to be like -3, -4, -5. So now I plug these numbers into my function of -3 halves x minus 1. I get 2, then 3.5, 5, then 6.5. Okay? Now from there, my starting point, which is going to be negative 2, 2, I need to determine if that's going to be open or closed. When we look at the inequality, there's no equal bar, so it is going to be open. But the rest of the points are going to be closed like normal. So I go over to the left 2, up 2, and I'm going to have that as open. Now I do negative 3 and a half, then 4 is going to be 5, and then I go up a half. Now, from here, once again, I go from my starting point, which is the open circle, and connect the rest of the points, and make sure you have an arrow to represent a ray. Okay, now let's do the x plus 1. Now notice this one's a little bit different. All the other ones we have done so far only had one part to their restriction. In this case, there's two parts because we have x is greater than negative 2, but it's less than 1. When you have two parts to your restriction, we need to include both of them on our xy table. Now, we're going to choose about 2 points. It kind of just depends on what you're doing, but we'll choose about 2 points in between negative 2 and 1. So we can use like negative 1 and 0, okay? So now we plug those numbers into our x plus 1, so I get negative 1, I get 0, 1, and 2. Now we have two starting points. Our first one is at negative 2, negative 1. Will this be open or closed? Well, we look at the inequality with it. Negative 2 is less than or equal to. That is going to be closed because it does have the equal bar. But what about the 1, 2? Well, for that inequality, x is less than or equal to 1. That also has an equal bar, so it's going to be closed. Now, just to let you know, when you have two parts, doesn't mean that both of them are going to have an equal bar. One could have an equal bar and the other one doesn't. Both of them might not have equal bars. It just depends on the piecewise function. So now we're going to go ahead and plot these. So I go to negative 2 and then negative 1. That is going to be a closed circle. Then negative 1, 0. And remember, everything in between is going to be closed, and then 1, 2. Now here, usually we would have a ray, but because we have two parts to our restriction, this is when it's going to be a segment. So we have a starting and a stopping. So there is no arrows when there are two parts. So we'll kind of talk more about when you have two parts to your restriction, it's going to be a segment. One part of the restriction is going to be a ray. Okay, so now our last one, we have 3. So remember, x is greater than 1. We start at the restriction, no matter if there is or is not an equal bar. Now, since x is greater than 1, is that saying we need numbers larger or smaller? Bigger. So we need 2, 3, and 4. Now, you might be wondering, well, how do we get the y's? I don't see any x's. Well, don't forget, when we just have a number that actually represents a horizontal line. So when we have a horizontal line, that means all the y values are exactly the same. So all of these are going to be 3's. Now our starting point of 1, 3, is that going to be open or closed? That is going to be open because our inequality does not have an equal bar. So I go to 1, 3, and that's going to be open. And then all the other points are going to be closed, and we have a horizontal line. So I go from the open, make sure you connect with the closed. And if you notice here that when we have the points really on the same x value, we have one that is open, one is closed. The reason we have that is it makes it a function. If both were open, that means not each x value has exactly 1 point. And that's the same if both of them were closed. Not each x value has one exact y value, okay? So having one open and one closed on the same x value makes it a function, okay? Okay, make sure you watch the last part. We're going to be talking about step functions, which are a type of piecewise function.